Now, angles. Which would be the initial, so initial side, which would be the terminal side? Just a guess.
The initial would be the bottom.
Okay, yeah. You got it. So probably some terms that you haven't heard because we don't have a formal geometry class anymore. Some of these things get glossed over. Okay. When we study angles, a positive angle will always go counterclockwise. Okay. Yep. What's this called?
Vertex.
Yeah, it's a vertex. Good. All right, so there's your angle vocabulary. We can set angles in the coordinate grid, which is mainly what we do in this course. Okay. So most everything that we do in angles is set in the coordinate plane. If I draw you an angle, okay, the initial side will always be the positive x-axis. Okay, so this would be 45 degrees. Okay. Ish, if my drawing's perfect. All right. What would it be if I went this direction? Yeah, we're negative 45 degrees now, indicating going clockwise. Okay. So this would be clockwise. This would be counterclockwise, right?
Why is that?
The whole dude decided that's how it was.
You know, that's probably what it was.
Is it just because, like,
But I don't know for
I
sure.
get it now.
I just don't
No, I
know.
get it. Yes.
My mathematics history is probably the weakest part of my mathematics training. So, ask me a history math question, I probably can't answer it. Hey.
Who invented pi?
Who invented pi?
That pi.
God. That I can answer.
Who discovered somebody?
This would be called standard position if you're looking for a vocab word. Okay, so we're good. If I have angles on the axes, what measure would this angle be?
90.
Yeah, we're at 90 degrees there. If I continued it to this 180, okay, and this would be 270. One full revolution, 360. Okay, almost sounds like you guys are good on that one. Questions? Bueno. What if we went 5.5 rotations counterclockwise? Okay. How many degrees is that?
So it's one rotation all the way around, right?
Yeah.
So it's 270, 6 times 5.5.
Okay, one rotation is 360, right?
Yeah.
Okay, so it's just a multiplication problem. 1980?
What?
You're the teacher?
Is that right?
Yes.
Okay.
I was actually born in 1980.
That is not the single best year in history.
No, I was saying what?
1981 was.
Why would
You were
that
born in 81.
Back in 1981.
First kid was born.
Okay, you can do the same with something like 3.3
He's an Ivory Coast.
rotations clockwise. The computer is running a little slow. So that would be negative 360, right? Because it's clockwise times 3.3. Anybody? We'll just take it right out of the book here, just for speed's sake. Okay, so there you go.
So clockwise is negative and counterclockwise is positive, right?
Right. Okay. Good enough. You guys can do that pretty easy. All right, coterminal angles. Use your English language knowledge. What could that mean?
Two terminals. Or like they work together.
Yeah, they terminate together, right? So if you have coterminal angles, they terminate in the same spot. Okay. So these are, they terminate in the same location. You can also say they share a terminal side.
So would that be like a...
So this would be somewhere in that neighborhood. Okay. Can you name a coterminal angle to 200 degrees?
Oh,
No, 0 is here. We need another angle that ends in this spot.
Oh.
Negative what? $160, right? That's 360 minus 220. The negative of 360 minus 220, right? Because we're going backwards. That 160-degree angle is coterminal. Okay. Can you name another one? You do not have to restrict yourself to one rotation.
420. 520.
How about 560?
Sure.
So it's one full revolution, right?
360.
Plus 200.
Oh, that's true statement.
So 560 degrees is also coterminal. Can you name another one?
Yeah, we'll do 760.
720 plus
Oh, that.
200. Can you just stop adding today? Thank you. Okay, so how many possible coterminal angles are there? An infinite amount, right? Okay. Sometimes you're going to be asked to name one. Okay, so this is name one. Coterminal angle. You could be asked to name all of them. Oh, come on, computer. You just can't keep up with my scintillating intellect. Name all computer. That's awesome. Here, I'm talking trash and I can't, right. Coterminal angles to 200 degrees. Okay, that's, so how do we know? Would you want to write them all out?
No.
I think seriously, no. I don't even think I would like to write for the rest of my life in eternity. It would suck. It'd be like rolling a stone uphill for the rest of eternity. So how could we note that in one simple phrase?
One revolution was
200 plus what?
Infinite revolutions.
In mathematical terms, like
The numbers
n? Did somebody say n?
Yeah, and I said
n times what?
360.
360.
Yes, that's the
So this would be, you remember what an integer is, right? Yeah, no? Integers? Positive or negative whole numbers? Right? So if I put 1 in here, I get a coterminal angle. If I put 10 in there, I get a coterminal angle. If I put negative 50 in, right? So this is how you note all possible coterminal angles. Kellen.
Where'd you get 326? Right there. Where'd you use?
What?
360 minus 326 is what?
220?
Or I mean 220. Where'd you get 220?
I don't know.
Minus.
Should we fix it?
Yeah.
That's a good question. How many times have I told you this year to keep an eye on me?
Too many to count.
Yep.
Okay, now.
No, not too many to count,
That's good.
just very many that you don't want to count, right? Because you can count that high, I hope.
I can only count to 20.
I don't know.
I would have figured it.
Isn't that?
I feel bad for you.
A, B, C, D.
Are we okay with that?
It's okay to some.
Okay. And, okay, here's probably the most important part of today, because it's going to affect the rest of your year. This all affects the rest of your year, but this is something that may be new to a lot of you. It's called a reference angle. Okay. You know what sine, cosine, and tangent are? Yes? Okay, so with right triangle trigonometry, you're always working on a triangle, correct?
Yes.
With sine, cosine, and tangent.
Those are all.
This angle is always, for now, has always been between 0 and 90 degrees, right? So that's 0 to 90 degrees for, okay. We are going to start dealing with triangles that are not that, that pretty, basically. Okay, so I might set a triangle here and tell you that this is 135 degrees. Okay.
You have to figure out what the angle is on this.
The reference angle
Use 40, subtract that.
is the angle between 0 and 90 that that triangle forms. Okay, this is the reference angle.
Is it asking us to find the length?
No.
Okay, so it might say, what is the sine of 135 degrees? Okay. You actually have to use the reference angle sine 45 because that's what we have the values for.
How do you,
Okay. So if you have a 135 degree angle, the reference angle is always the angle formed with the x-axis. Okay, so it's the acute angle formed with x-axis. So what is that reference angle there?
45 degrees.
45.
Yeah, 180 minus 135, right? Okay, very, very important that we understand that concept. Being able to find a reference angle. Okay. Let's try.
Yeah, so with the sine of 135 is 45?
Sine at 135 degrees is the same as the sine at 45 degrees. We'll get more into that, but just for now, be able to understand what a reference angle is.
Okay.
Okay, so if I give you a 260 degree angle, somewhere in there, right? What is the reference angle? Okay, where are we closest? We're closest to this part of the x-axis, right? So this is your reference angle right here. It's acute. We do not want to use this one because it's obtuse. Don't be so obtuse.
Are you always going to be going from the x-axis?
Yes, it's always referenced on the x-axis, the closest part of the x-axis, right? So
What if it's right in the middle?
then it's a 90 degrees.
Oh.
There you go. Okay. So 260 minus 180 is 80 degrees. There's your reference angle right there. Okay. And again, we could throw a myriad of those at you. The key is that it's closest to the x-axis.
So what do you do with the reference angle you calculate?
We're going to get to that later. Can you just trust me on that one? No. Yes, can, shouldn't.
Roasted.
But it's best to take little chunks at a time. Well, Caleb Frank eats entire steaks at a time, apparently, instead of taking bites. We're taking bites.
I choked
Okay.
twice.
Are you okay with that? You can figure out what reference angles?
It's just whatever.
So all you're doing today is calculating what a measurement of the reference angle is.
Not too bad.
Okay. No, it's not. It's just something you've probably never seen before because you've never had to deal with it. Good? Okay. That is the lesson. There's something in this section we did not do, dealing with navigation on degrees, minutes, and seconds of angles. Okay, so just the big idea. How do you deal with that type of an angle in navigation? Because our GPS system is degrees, minutes, seconds. How do you break that into degrees, minutes, and seconds? That's what we skipped today. So if you see a problem like that in the reviews that shouldn't be there, just know. We just didn't deal with this. And it's just something that I choose not to. If you're going to be an airline pilot, you can learn that in about 10 minutes and it's good to go.
Nice.
All right, good to go.
I have no idea what it is. I was like, oh, that was pretty good. Is it all there?
What in the world?
Literally 17 billion BC.
Okay, back to it.
I love homework. Yay, homework, bro. Oh my goodness, I'm so happy.
Well, I'd say you have a half an hour. Hopefully it's not homework and just classwork. But that's up to you.
Even if you stop stealing, this is all I have.